All right. So, who's got a homework question? Give me what the assignment was and what the problem number is. Madeline?
Homework 6-3, can you do 4B?
6-3, 4B. 6-3. Oh yeah, a lot of people missed this one. Not totally. The directions say, raise the Cartesian equation. So that means we're gonna eliminate the t, right? So what some people did was say, okay, I'm just gonna take that top equation and t will be the square root of x. And so my equation is the square root of x plus 1. Now, I get that, but there's something missing. What's missing? If you're going to do the problem that way, what is missing? David?
The plus or minus.
Yeah. If you're to do that, it's perfectly okay, but you've got to have that plus or minus. Whenever you take the square root, whenever you do this, you have to do plus or minus, unless there's some compelling reason that it couldn't be both. For example, if x represented, or if y represented the side of a triangle, obviously you don't need the negative, right? But almost all of the time, when you square root, you gotta do the plus or minus. Now, you could avoid that. There's nothing wrong with doing it that way. You could avoid that by just saying, okay, well, t is y minus 1 in this equation right here. So x equals y minus 1 squared. That would take care of it, and there's no issue there. Anyway, there you go. All right, Robert?
3 on 6-3.
3 on 6-3. Okay, yeah. Most everybody got part of this right. So I'm doing this without a calculator. So I think I'm going to go ahead and do the same thing I did over here. I think I'm going to change it into a Cartesian equation. So these are the ones, when they have cosines and sines in them, we like to square both sides. I'm dividing by 2. And now I'm going to square both sides. And what did I do that for? What's going to happen now? David?
Want to turn into a circle equation?
Well, I'm going to add, and what happens when I add cosine squared and sine squared? I get 1. So remember, if you want to get rid of the t's, you're going to have to get rid of the cosines and sines too, right? And that's not as easy as over here where we just substituted it out. So when we've got these functions in there, squaring them allows us to cancel them out basically and say 1. So you have x squared over 4 plus y squared over 4 equals 1. Or x squared plus y squared equals 4. If I just multiply out the fractions. That's your circle equation. No question about it. That's a circle centered at the origin with a radius of 2. And a bunch of you are saying, well, Mrs. Ward, that's what I graphed, and you marked it wrong. Why? Why is that wrong, Ronson?
Because it's 0 to pi.
Exactly. Your parameter is running from 0 to pi. That picture is doing what?
0 to 2 pi?
Yeah. So we only need the top half of the circle. 0 to pi. Okay, got that? All right, what else have you discovered? What else is wrong on any of the homeworks from chapter 6? So not just the ones I handed back today. Any of the ones. This test is over the whole chapter. So some of those I handed back a while ago. Any of them. Sarah?
Also on 6-3, number 5.
Kirby hits a ball when you're just 4 feet above the ground. parametric equations, when the ball is hit at an angle. Do you remember those parametric, what are the parametric equation? What's the format of them when the object is going up? Not straight up and not straight down, but going at an angle.
Negative 16t squared plus v naught t plus s original.
Okay, now, that is the general equation for, projectile motion. But there is something special I have to put here, and something special I have to put here.
Oh, x cosine or sine theta.
Yeah, so what was my velocity? 120, so this is gonna be 120 cosine 30 is my coefficient on t for x, and then 120 sine 30 is my cosine, or my coefficient on t for y. And you won't get that confused if you remember what you're supposed to do, because you're used to x going with cosine and y going with sine, right? So you're not gonna get those mixed up. All right, now, if you want to go ahead and simplify that, you can, because you know what the cosine of 30 is, root 3 over 2. So if you want to do that, you can, or you can just type this in on your calculator, because that's what you're going to end up doing anyhow. Okay? Now, when we type it in on our calculator, shoot. Alright, let's type it in. We gotta be in parametric mode to do this. No, I've got another. I just don't know where mine is. Let's check my instrumentation box one more time. Oh, crap. I lost mine. Okay, now let's put it in parametric mode, and here we go.
This one.
Yep.
Would you put a 4 at the end of the y equation?
Oh, yeah, I forgot to put that in there. Is that how high it is when it's?
I think
Yeah,
so,
yeah, thank you. I forgot about that. I'm all shook up. All right, so I gotta go change into parametric mode. I'm gonna be in degrees, right? Type in my equations. Oops. With these guys, parentheses are so important. So make sure, okay, so we need these parentheses. This is the coefficient on t. But when you start typing this in, parentheses are automatically gonna pop up there. So make sure that you've got enough parentheses in there to make it work. Same thing's gonna happen down here. Okay, well, I just hit graph without changing anything in my window, so I better go to my window and make some changes. What do I need T to be? Now, be careful. T is this guy right here, right? And what does T stand for in this problem, do you think? Time? So think about hitting the ball. I don't know, what would be a good, well, certainly 0 would be a good minimum. What would be a good maximum, do you think? Huh? 10? Sure, that'll work. All right. Now what about for x? probably 0 for a minimum. And what do you think for a maximum? Let's read our problem again. Our maximum is gonna have to be what? Bronson?
350 or a little bit more maybe?
Yeah, I think I'll just go with 400. And my Y minimum is 0. And what do you think about my Y maximum? I don't know how high this ball's going. I don't know, maybe 50. Let's see what happens. Well, that's not quite high enough, but it doesn't really matter because what's my question? I got a parabola, right? So what's my question now? Is the ball going to clear the fence? So I'm just gonna hit my trace button. And I'm just gonna go along my graph until I get to what? What am I looking for? X to be 350. All right, now when X is about 350, how high is Y?
23-ish?
Yeah, about 23-ish. How high does Y have to be if it's gonna clear the fence? 30. So is the ball gonna clear the fence? No, it's not high enough, right? It's gotta be 30 feet, it's gotta be more than 30, and it's only 23. All right, now, pretend you're the outfielder. This is the fence. I'm the outfielder. Right here I am. Right? Here comes the ball. Ball's not gonna go over the fence, right? But when it gets to the fence, 350 away, how high did you say it was up in the air? 23 feet. Is a normal human being gonna be able to catch it when it's 23 feet up in the air? No, it's still too high. Now, some of you went into great detail. Well, it'll bounce off the fence and land on the ground. No, the ball is too high for someone to catch it at that point, right? Okay, what else? Homework. What other questions do you have with homework? You need to remember this setup, by the way, okay? So you need to remember that your coefficient on T is your velocity cosine, and your coefficient on T here is your velocity sine. Okay, what else? Anything else? Ava?
On 6-5, can you do 2A?
6-5, 2A. Yes, I need to get my notes out though, because we need the tests of symmetry, and I told you did not have to remember those. So I will provide you with the tests of symmetry if you are required to do it. Oops, where's the problem? 2A. We're testing to see what, if anything, this is symmetric about. Now, remember, the tests of symmetry, which are in your notes, we're going to use them, those are not both and. They are either or. So you test it, each one, well, x-axis, y-axis, origin, has 2 tests. So you pick one, doesn't matter, pick one. If it works, great, move on. If it doesn't work, you have to try the other one. Because one of them might not work, but the other one will. And that's all that matters, is one of them works. Okay? So the first test I'm doing, I guess x-axis first. The first test for the x-axis says, put in a negative theta into your equation. So r equals 1 plus 2 cosine negative theta. All right? What happens when you take the cosine of a negative theta? What happens to that negative? It disappears. No, it disappears. Cosine is even. Cosine is even. So when you take the cosine of a negative, it doesn't matter. In other words, the negative on the input does not affect the output. The cosine of 30 is exactly the same as the cosine of negative 30. Okay, we're supposed to know that. There are only 2 functions that work that way. Cosine and secant. Everything else is odd. So all the rest of them, the negative would come out. but for cosine, it drops. So this equation is exactly the same as this one, which is exactly the same as the original. So do we have symmetry about the x-axis? Yes. Done, move on. You don't have to check the other one. You just need one of them to work. So now we're going to y-axis. The first test says make them both negative. So negative r equals 1 plus 2 cosine negative theta. Now we just talked about that is going to become 1 plus 2 cosine theta. So is this going to be the same equation as the original? No. So that test didn't work. So now I got to go to the second test, which says replace theta with pi minus theta. Okay? Now, this is where we need our colored sheet, unless we have them memorized. We need our colored sheet because we have to evaluate the cosine of pi minus theta, which is the cosine of u minus v in the vocabulary of your colored sheet. So cosine pi minus theta is cosine pi cosine theta plus sine pi sine theta. That's the formula. Okay? What's the cosine of pi? Watch it. Cosine of pi is -1. So this is negative cosine theta. What's the sine of pi? 0. So this whole thing that disappears then, this thing boils down to negative cosine theta. So this right here is negative cosine theta. So this is 1 minus 2 cosine theta. 2 times negative cosine, negative 2 cosine. Is that the same equation as the original? Nope. So we do not have symmetry about the y-axis because neither of the tests worked. All right, now the origin. The first test says put in a negative r. So that would be negative r equals 1 plus 2 cosine. No, right? That's not gonna work. So then the second one says put in a pi plus theta. Or theta plus pi, same thing. All right, so now I need to do this and figure out what this is. So cosine pi plus theta is cosine pi cosine theta minus sine pi sine theta. That's right off my colored sheet if I don't have it memorized. U minus v, or u plus v, I mean. All right, so once again, the cosine of pi is -1, so this is negative cosine. That's 0, so that's gone. So r equals 1 actually minus 2 cosine theta, because this right here is negative cosine theta. Well, that doesn't match either. So the only one this has symmetry about is the x-axis.
When would that first equation for the origin ever work to be symmetrical?
Well, if you had a lemniscate equation and that was squared, r squared,
Oh, okay.
right? But I think that right off the top of my head, I don't know
Okay.
about.
What would have to happen for the, for any cosine equation not to be reflected across the x-axis? Because if you plug in the negative for the theta and it just disappears, then
I guess it's always gonna be symmetric about the x-axis. I hate to say always, I hate that word, because there's usually some kind of exception, but yeah, that, if all you're doing is changing that, now, if your equation had, let's say, was theta plus 2 cosine, that wouldn't match then. But as long as the only theta was attached to a cosine, yeah, it's not gonna matter. Okay, there we go. All right, what else? What else do we have for homework? Let's stick with homework and we'll look at our quizzes.
6.4, number 7.
6-4, number 7. All right, this was actually a much easier problem, and some of you picked up on that. Some of you did just a beautiful job with it. So, if we look at, the plane's courses are given in polar coordinates. So, that makes it super simple. Here is 12 degrees, and the magnitude of that vector is 4. That's the first guy. And the second guy is 72 degrees. Oh, and he's only 2. And we want to know how far apart they are. So basically, we're in a triangle, and we know both of these sides, this one's 4, that one's 2, and actually, don't we know the angle here between them? That is 60. So that's a law of cosine's problem. So x squared equals 2 squared plus 4 squared minus 2 times 4 times the cosine of 60. And since the cosine of 60 is a half, we have 4 plus 16 minus 8. So x squared equals 12, and x is the square root of 12. Since the plane's courses were given in polar coordinates, we didn't have to worry about the angles, they were already in standard form. One of the biggest issues is, when you're doing these navigation type problems, is making sure you're using the right angle. Well, here, they gave us the right angles. They gave them to us in standard form. Okay? All right, what else from homework? What else, Madeline?
6-4, number 5.
Rewrite as a polar equation. What's x? X equals r cosine theta. So I would just straight substitute in 3r cosine theta minus 4r sine theta equals 7. Now, that is a polar equation. It's not considered to be in graphable form. So if we wanted it to be in graphable form, what does that mean? If I'm going to graph it in polar coordinates on my calculator, what does the equation have to look like? R equals. So I'm going to factor that R out and divide. Now it's in graphable form. So if I wanted to graph it on my calculator, it should be a line. If I wanted to graph it on my calculator, I'd have to make my equation look like this. This is a polar equation though, so this was fine for this problem. But make sure if it says graphable, you get R by itself. Okay? All right. Tommy keeps putting his hand up back there. Tommy, what's your question?
6, 5, 5, 8.
6, 5, 5, 8. What did you say?
Why did I said 3? But I know it's
3?
because it was squared. Is that not cheated?
Did you mean like 3 point something? Are we looking at problem number 5? A.
The pedals?
Yeah. How long they are?
Yeah.
Okay. Well, the number out in front, so if you have a rose equation, this is not a rose, but if you had a rose equation like this, the number out in front is the amplitude number that controls the length of the loops. So these would be 5. When you put a squared on there, r equals the square root of 10. So the roots are root 10 long. So did you graph it on your calculator? And then, yeah. So it's 3 point something, the square root of 10 is 3 point something, but that's the length of the leaves right there. David?
I just didn't know how to do number 3 on 6-5.
6-5, number 3. Remember, every equation in the whole wide world that has 2 variables in it. One of the variables is independent and the other one is dependent. So if I said to you, I want you to graph r equals 2 plus 3 cosine theta. Without your calculator, so in other words, I want you to set up a t-chart, just like you normally do, like with x's and y's, only we're going to set it up with r's and thetas. What would you do if I said, okay, we're going to do this now, but we're going to plot these points by hand? What would you do?
Start putting numbers in
For what?
for data.
For theta. So theta is your independent variable. So if you let theta be 15, then that's going to give you an r value. The value of r depends on the value of theta that you put in, right? Now, theta can be anything. I mean, this is a degree measure, but 0 to 360 and even beyond if I wanted to go farther. R, the value of r, is going to depend on those thetas that you put in. So I want you to think about this right here. What is the absolute biggest, or wait, this is minimum? What is the absolute littlest that cosine theta can be? Remember, r depends on cosine. So the littlest cosine is going to give you the littlest r. Does that make sense to you?
Yeah.
All right, what's the littlest cosine?
Is it 0, 1?
Someone's smacking. Think about cosine. Think about what cosine looks like. What's the smallest value it can have?
Oh, -1.
The cosine, the minimum cosine value is -1. Cosine goes from -1 to +1. If you type in on your calculator cosine anything in the world, it will never be less than -1, right? So the smallest this can be is -1. So what's the smallest r can be?
Also -1?
Yeah, it just happens to be that way because of the numbers that are in here, but yeah, -1. Now, what some of you did is you graphed this thing on your calculator and then you traced around till you found, I guess, the lowest point. But what you need to understand is in polar coordinates, minimum doesn't mean low. In rectangular coordinates, if you want the low point, you look for the lowest point, right, the minimum? But in a circular system, that's not how you do it. That isn't the low point of the graph. So some of you said like point something or other because you traced around. That's the lowest point on the graph, but it's not the minimum point on the graph. Minimum R value. All right, what else? Anything else from homework? Let me see quickly. On your graphs on 6-5, some of you were not careful at all, and we didn't talk about it, so maybe that's why, but I need you to be more careful when you're graphing. So for example, on the rows, which is problem B on the sketches, how long should your petals be? When you draw your sketch, you know they need to be how long?
3.
They need to be 3, or no, they need to be 4 units long. Those petals need to be 4 units long. What does the 3 tell me?
It's not.
There'll be 3 of them, which of course your picture showed you that. But those 3 should be evenly spaced, right? How far apart? How many degrees apart? 120. So you gotta figure out where one of them is, and then the others are gonna be 120 apart. okay, when you draw it. Similarly, A was your limacon. It did not have an interior loop, but it had a little indentation, right? How big is that limacon? What is the biggest R value that limacon can have? 5. So it should fill the graph. Some of you drew, you had the shape right, but you drew your little limacon that looked like that. No, it fills the entire graph because its maximum value is 5, so it goes all the way down to 5.
How would we have done C? Because the window had to be really big to see it, so how would we do it on this one?
Well, that one, plotting points, probably isn't it, just that's a general shape.
Okay.
That's a general shape. And yes, the window would have to be really big. So if you were actually formally doing this, you'd have to change the scale so that each circle was worth 100
Okay.
or whatever you needed it to be. That's a spiral of Archimedes, right? Yeah. Okay, let me see what else we missed. Did we miss it? Oh yeah, there's one more I want to talk about. Maybe we already have. Have we already talked about on 6.4, number 3A, or number 3, there's no A? 6.4, number 3, have we already talked about this?
No.
All right, we need to talk about it because there are a couple of things that we need to get straight. Okay, so find all polar coordinates. Remember, every point in the polar plane is describable with infinitely many ordered pairs. So your job is to write them all. Obviously not individually, but write them all. So let's start with the first one, just the most common, the basic one. We're going over 1 down root 3. What's R? 2. What's theta? Now this is going to be theta right here. So this would be 60. So theta is 300. So our starting point is going to be 2, 300. That's the beginning. But could I have said 2, negative 60? Would that also describe that? Yes. In fact, any angle coterminal with 300 is going to be okay. Because if it's coterminal with 300, isn't it going to describe that very same vector? So how do we do coterminal angles? We add and subtract revolutions. So there is your first set of answers. Now, those of you lazies that don't put this down, I'm going to mark it wrong. Because if you're walking down the hallway and you find a slip of paper that says plus or minus 360 n, you have no idea what that means unless you know what n is. Right?
This might be a really dumb question. What does that bit on the end mean?
This means n is an element of the whole numbers.
Okay.
That's notation you learned in geometry.
Okay.
So n belongs to the set of whole numbers. So n is 0, 1, 2, or excuse me, n is 0, 1, 2, 3, 4, 5. Okay, now this describes every single polar coordinate pair with a positive r. But r can also be negative. So what happens if r is negative? Go back to the original angle. What happens to your angle if you change the sign on R? Robert?
Add or subtract the rate.
Yep, it flips opposite. It's the opposite angle. So think of your circle. Think of this as 300, then the opposite angle would be here, which would be 120. And then all of its coterminals. So that's the answer to that question. Got it? R can be positive or negative, and then you have to consider all of the coterminal angles. What does the word exact mean? No calculator. You guys, you're gonna miss stuff if you don't pay attention to the directions. When it says exact, gotta have no calculator. Okay. Let me see if there's anything else I can think of that we missed a lot of. Well, that was all on the quiz. All right, so let's look at our quizzes then. let's look at our quizzes. Any questions about those? Let me find them. Okay, Bronson.
On the 6.1 and 6.2 quiz?
Yep.
Number 5.
All right, so number 5. This actually was a homework question also, so we're trying to kill 2 birds with 1 stone here. So we want to find the actual speed and direction of an airplane traveling, okay, da, 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 da. So we're gonna have to resolve this into its components. So we got the plane, so we'll have an X and a Y for the plane, and we'll have the wind, we'll have an X and a Y for the wind, because what we're really looking for is the resultant of those two, right? What happens, the plane starts off this way, but then the wind blows in, how does he end up? What is the sum of these? So, let's look at the airplane first. 382 miles an hour on a course of 220 degrees. Okay. A course of 220 degrees. So that would look like this. Agreed? Because it's a compass. However, when I go to do r cosine theta, theta has to be in standard position. So we can't use 220 because that isn't in standard position. We need to use this angle. So we gotta figure that out. Okay, well, let's see. How could we, what would be some logic we could use to figure that out? If this was 220, what are you thinking, Bronson?
You subtract 90 from it because that'll give you the negative angle, and then
This one, you mean?
yeah, sorry, from the original one,
Okay.
220 angle. If you subtract 90 from it,
Okay,
that will give you the quantity of your negative angle,
yep.
and then you can just do 360 minus that.
Oh, okay, all right, that'll work. Does that make sense to everybody? He says, figure out what this part is right here. Figure out what the orange is, and what would that be, 130? So this angle, this orange angle is negative 130, so what is the red angle actually going to be then? Positive 230? So x equals, what was our speed? 382? 382 cosine, shoot, what did I say, 230? And 382 sine 230. Everybody follow that? Now we're going to do the same thing for the wind. The wind is on a course north 68 degrees west. So north 68 degrees west. This is the wind. But don't use 68. The angle you need has to be in standard position, so it's this one. Well, that's a little easier. That's going to be 90 plus 68. So how much was the 28 miles an hour? So 28 cosine 158 and 28 sine 158. Okay, I can't remember who asked about this problem, but are you okay? All right. So now we're going to find the sum. So the resultant, the sum, is going to be those two added together. So I'll just go ahead and do it on my calculator. No need to round it off. I'll do 382 cosine 230 plus 28, just 28 cosine 158. I got negative 271.51. Oh shoot, am I in degrees? And then 382 sine 230 plus 28 sine 158. right, now, what does that represent? Well, that represents the airplane's velocity vector. So he is down here, negative 271.51, negative 282.14. This is going to be his actual speed, right here, the magnitude of that. So I'll square those two numbers. So 271.51 squared plus 282.14 squared. Square root it. I got 391, so I have his actual speed as being 391.56 miles an hour. And then his actual course will be this right here. Right? Measure from due north. So I'll find this guy doing second tangent, 282.14, divided by 271.51. And I got this angle to be 46.1. So his course will be 270 minus that, 223. Okay? There's a lot to that problem, but really the only part that catches us is getting these angles right. You gotta get the angles right. But the rest of it's pretty straightforward. All right, anybody else have a question about the quiz?
Can you do number 4?
Yep. Find the work done. You gotta remember that work, how's work calculated? Force times distance times cosine of angle between. So here, the work is going to be force times distance times cosine of angle between. So that's what I gotta figure out. All right, so let's see, what do we know about this? Well, we know that we have a force and a distance, and we know that the force is in the direction 3, 2. So here's the force in the direction 3, 2. Wait. Modify that a little bit. All right, so that's the direction of the force, right? 3 up 2. The movement, the distance, is along the line y equals 0.2x, which means how's it moving? Over 10 up to the slope? 0.3. How did I get 0.2? I don't know. 0.3. So anyway, it's going up 3 over 10. So he's right here, up 3 over 10, his coordinates look like that. So this is the direction of the force, this is the direction of the movement, of the distance, and we need to know the angle in between them. Well, look, I think the easiest way to do that is to do the dot product. So if I dot these two vectors, 3, 2 dotted with 10, 3, that's going to be 36, right? 3 times 10, 2 times 3, 36. But it's also the magnitude of the first vector times the magnitude of the second vector times the cosine of the angle between them. So 36 equals the square root of 1417 cosine theta. So what's the cosine of theta, which is what I need up there? The cosine of theta is 36 over root 14/17. And that will give you your answer. You type that in. Now you could also find the big angle by doing second tangent 2/3. And then you could find the little angle by doing second tangent 3/10, and then subtract them. And that would be theta, and then take the cosine of that, and that would also give you the answer. Alright, is that it? Alright, let's get out our review sheet. I handed those out already, didn't I? Hope I did, because I don't have them up here. So let's get out our review sheet. Remember that anything that we've talked about, anything in the notes, is fair game. The review sheet is just to get you started thinking. You guys start practicing how to study math. All right, so has anybody looked at the review sheet yet? All right, then I'm gonna start with problem 12, and I'm gonna tell you right now, you better look at it, you better find some things you wanna work on next time, tomorrow, or we'll take the test tomorrow. Got it? Okay, review time is a waste of time for me. This is a complete and total waste of my time. Why are we doing it? For you. If you don't care enough to do a little bit outside, then we won't do it. Alright? Alright, I'm gonna do problem number 12. Because that looks interesting. Okay, so our job is to solve for z in complex form. So this, remember, oh, there should be an I on there. Oh, sorry about that, put an I on there. There should be an I on there. Let me fix that. Okay, so I really don't want to FOIL. I could, but after I get it all FOILed, I'm gonna have to square root it. I really don't want to do that. So what do you suggest, Bronson?
First I would square root it and change the exponent to 5/2.
I think that's a wonderful idea. You can do the problem in 2 steps. You could certainly use the MOV and raise this to the 5th power, and then turn around and raise it to the 1/2 power. But the MOV works with every exponent. Every exponent, positive, negative, fraction, doesn't matter. So why do it in 2 steps when we can do it in 1, right? Our power is going to be 5/2. So we're going to change this guy into polar form. So what's R? 2. What's theta? Now be careful, you know your reference angle is 60, so theta is going to be 120. Caution, caution, caution. Get your theta right. Because if you miss your theta, all these are going to be wrong. So take the time to make sure you've got your angle in standard position. So 120, we're going to raise that to the 5/2 power. All right, so what does the MOV say to do? Take power, or take R to the power. So 2 to the 5/2, CIS 120 times 5/2, which is 300. There's answer number 1.
You wouldn't want us to, figure out what 2 to the 5 halves is?
Now at this point, I got an answer in complex form, so I'm gonna have to take care of that in a minute, but right now, there's nothing wrong with that. How many answers does this problem have? 2. Why does it have 2 answers? Because we are square rooting. And when you square root, you get 2 answers. Well, Ms. Ford, what about the 5? 5 has nothing to do with it. When you raise something to the 5th, there's 1 answer. It's only the roots that give you multiple answers. So, 2 answers, 180 degrees apart. So the second answer, well, if I added 180, I'm gonna be too big. So how about if I just subtract 180? That'll work, won't it? Isn't adding 180 gonna put me in the same spot as subtracting 180? Okay, so here are my answers. These are beautiful answers, but those answers are in polar form. And the directions say answer in complex form. So now I have to figure out the x and the y for each of these. So for the first one, x will be 2 to the 5 halves cosine 300, and y will be 2 to the 5 halves sine 300. Everybody in agreement? All right, well, so let's talk about what 2 to the 5 halves means. 2 to the 5 halves means the square root of 2 to the 5th, which would be, if you wrote it all out, root 2 times root 2 times root 2 times root 2 times root 2, right? Each of these pairs becomes a 2. So I have a 2 times a 2 times a root 2. So isn't that just 4 root 2? Now, what about the cosine of 300? Well, here's 300, reference angle 60, sides of the triangle are those. So what's the cosine of 300? What's the cosine? 1/2. So my x-coordinate for my first number here, my x-coordinate is just going to be 2 root 2. Now what's this? I'm not going to do the same thing, but I'm doing the sine. So I'm going to have 4 root 2 times the sine. What's the sine? Negative root 3 over 2. Now, when you multiply root 2 times the root 3, you're going to get a root 6. So this is going to be negative 2 root 6. Is that okay? Now, you can do the second one the exact same way. Only the angle you'd be drawing is 120. I think we talked about this the other day, though, with square roots. With square roots. They're exactly 180 degrees apart. So what was in quadrant 1, or actually what was in quadrant 4, will now be back in quadrant 2. And isn't the reference angle for 120 the same as the reference angle for 300? So can I just kind of shortcut it a little bit and say, okay, in quadrant 2, I'm gonna have this? That's perfectly legit. Don't be doing that with 5th roots. But it's perfectly okay to do it with square roots because they're exactly opposite each other. Perfectly okay. If you're uncomfortable with it, then just work it out like we did here. Because that will never fail you, right? Andrew?
So if you...
Oh, Philip, yeah. That's right, good job.
If you, write them in like the coordinate form, you don't lose the I, but if you write them in the equation form, you lose the I.
Oh my gosh, Andrew, or Philip, whoever you are, you're exactly right. Oh, Mrs. Ford just committed a cardinal sin. These are ordered pairs, so no, Philip, you are right. this needs to be written like this. And this one needs to be written like this. Because these are numbers, not ordered pairs. Yeah, you're exactly right, thank you for pointing that out. These are numbers, they started with an I, they gotta end with an I. Actually, they didn't start with an I, because I forgot that too. But, it was with 7 I. Alright. Let's see. Alright, I'm gonna stop. This gives me a good start on the review. I think I starred things that you can use a calculator